right, let's take a look at applications of trig functions. A little bit of this is review. These won't actually be too bad. There's a couple new terminology, things that we'll have to talk about, and hopefully it'll be pretty fast. So let's first start out with solving a triangle. Today is all about solving triangles, and then we're going to apply triangles in real world or something. So let's go ahead and say that this angle right here is 34 degrees. And then I get this side right here will be 10, and this side will be x, and this side will be 2. Okay, what we want to try to do is apply the trig functions that we have, and we've done pretty much two different types of trig functions. The first one is they give me an angle, and I want to try to find a side on a triangle. Okay, the second one is if they give me the sides, I want to find an angle. Okay, if I want to find a side like this one, I use the normal trig functions, just regular SOHCAHTOA. Okay, if I want to find an angle, then I use the inverse trig functions. Okay, so it depends on what you're trying to find for which trig function you're going to use, and you have to decide which one you use depending on the problem. Okay, on this one, I'm actually trying to find sides. Okay, I'm trying to find these two sides, and they give me this angle right here. Okay, so if I were to, let's say, solve for x right here, you first decide which trig function that you're going to pick here. Right, so which trig function would you probably pick there? The tangent, probably, right? Because you have opposite right here is x, and then 10 is the adjacent. So we would just pick the tangent. We go tangent of 34, and that would equal opposite over adjacent. So opposite's x, adjacent is 10. That's my basic set. You guys are probably okay with that. Most of this is review. Okay, now I take the tangent of 34, and to get the x by itself, I multiply by 10 on both sides. By 10 here and by 10 here, these cancel. And I get x equals whatever that is in my calculator. Feel free to put it on your calculator. Okay, so what do we get? We get 10 tangent at 34, and I get 6.7. Okay, so x equals 6.7. Everybody happy? So far, so good? Get my big fat head out of the way so that Mark can see it. Okay, pretty straightforward, right? Now, what if I want to find out what y is? A couple options. Pythagorean theorem is one option. What's another option? Almost the same thing. You use the sine, right? We'd use the sine, or I guess we could use the cosine, right? You can cover this one up right here. Now, there's all different ways to do that, okay? We can use the Pythagorean theorem, you can do sine, you can do cosine. You have pretty much free reign on which one you want to do. Now, what I would do, just me personally, what happens if you screwed up on the 6.7? What if that number wasn't right?
Whoever wants to go and do that.
Okay, feel free. Look over that way.
Oh, that way?
That way, yep.
Why over there and it's like death over there?
Death over there, but okay over there?
Yeah.
Okay. Don't go over there. Death is bad. So, anyways, this is what I was saying. With this 6.7 right here, what if I got that wrong? If I got that wrong and you did Pythagorean theorem, you're guaranteed to get that wrong, right? Wouldn't that kind of suck to miss one and then guaranteed to miss the next one? So what I would do is if you can just ignore that you even did that and just try to find y that way, you're guaranteed to have those numbers at least being right. So you might as well reuse the ones that they gave you. Give you a better chance of getting the right answer maybe. Okay. So on this one, I would actually use probably the cosine, right? Adjacent and hypotenuse. So I would use the cosine, and squiggly the line here, cosine of 34, and this is going to equal adjacent over hypotenuse, so 10 over 1. Okay. Feeling pretty good about that? Too bad. That's one way to do it. Yep. We got to get the fraction out of there, so you multiply by y on both sides. So that would put me in a y here and a y here. I'll show you in a second. So those y's cancel. So I get y times the cosine of 34 equals 10. Now I'm solving for y here. So I got to get rid of this cosine of 34. I'm multiplying. So divide to get rid of it, right? So you're just going to go divide by cosine of 34 on both sides. Cosine of 34 divide by cosine of 34. So these cancel. You get y equals whatever 10 over cosine of 34. Okay, y equals 12.1 roughly after the round. Okay, so I get 12.1 for this one. It's 0.05 something, hopefully. Did you use this number? Yeah. And did you round? See, better off using the ones that you're a little off. All right. Your round would have been wrong, and I would have had to mark you wrong. I would have felt bad about it too.
I'm sure you would.
Later, can you show me how to insert the interim?
I can show you that, yep. But later. All right, now the other way to do this, let me just do the setup again, because I think some people might think of that a different way. Okay, so let me erase this guy right here. Setup is still the same. It's cosine of 34 equals 10 over y. Now another option here is to put this over 1 right here and do like a fancy cross multiplying trick, which is multiply those two, multiply your cross products, and then divide by the odd man out. So 10 multiplied by 1, which is 10, divided by cosine of 34. A little bit faster way to do it maybe. You guys remember that shortcut from back in the day, right? Okay, cool. So anyways, that's another option where life is good. Now in this one, we were finding sides, so we just used a regular trig function, sine, cosine, tangent, and you can always do it usually with those three right there. Okay. Now let's say I wanted to find an angle, which is pretty much the same concept. But let's say I threw this guy here, and I wanted to find this x degrees right here, and then I'll know that this is like 10 here, and then a 15 here, and then a y. You were thinking about it, weren't you? You'll call me on the next one, so I'm sure. Okay, so now this one I'm actually finding an angle. I'm searching for an angle. You guys could all find y with Pythagorean theorem. And that would be purely accurate there because 10 and 15 were given. So you might as well use those to find this third side, Pythagorean theorem, nothing wrong with that. Okay? Or you could use a trig function after we figure out what this angle is. Okay? Now this angle right here, if I want to find that, I would use the 10 and 15. And you pick which trig function to use there. This one we would use the sine function. So we have sine of x degrees equals opposite over adjacent. So it's 10 over 15. Now to find out what x is, I got to get the sine out of there. Okay, and so since I'm finding an angle, this is where you use that arc sine. Okay, so we're going to use x equals the arc sine, which is sine to the negative 1, or second sine on your calculator. Just put second sine or sine to the negative 1 of 10 over 15 on your calculator, and that's going to give you your angle for it. Okay, so second sine, 10 divided by 15, and I'm getting 41.8. Okay, so x equals 41.8. Okay. Now, once again, if you want to find y, you could use a trig function and use the 41.8. But what if you get that wrong? What if you get that number wrong? And then it's all messed up. So you might as well use those, do Pythagorean theorem to get that set right there.
Does that arc sine thing work? Because sine to the negative first, or sine to the first times sine to the negative first equals 1.
No, equals the number on the inside. So if I do sine to the negative 1 of the sine of x, that equals x. That equals whatever's on the inside right here.
But it doesn't sine represent sine to the first?
Sure.
And then cancel.
Okay. The signs cancel out.
Yeah, and
So
then
this,
left.
it's crude, ugly math, but if you did those two right there and you added those exponents together, right, that would be like the logical thing to do. That would give you the 0 power, right? Sine of 0 power is 1, right? 1 times the x. Now that's crude, ugly math. I should stop the recording right now because that's a really bad thing for me to say. But these two cancel each other out. Yes, they're inverses of each other. So they undo each other. Settle down. Everything will be okay. All right, cool. So we get the x 41.8 degrees. Find this third side, Pythagorean theorem. I don't know if anybody actually did that yet, but 11.2. So 11.2 roughly, with some round. Okay, so that's how big this is. And I did that with Pythagorean theorem. Okay. What's that? Or you can use a trig function. That's also fine. Okay. All right, so all of your triangles you'll be able to solve this way. You'll be able to solve with either finding an angle using an inverse trig function, or you find a side, use a regular trig function on that one. Okay? All right, cool. Now let's go ahead and take a look at a couple of the new terminology things we're going to talk about. One of them is called an angle of elevation. I always feel like I spelled elevation wrong. Does that look right?
I was doing the essays.
This is the one that
Which one's in
E-L-E-V-A-T-I.
I think it's good.
Yeah, okay.
I think it's good. Okay, now the idea of an angle of elevation, you might have heard of this term before. It's pretty straightforward. The angle of elevation is from a horizontal line looking up. So if I've got a flat line, like so, and I look up at a certain angle, this angle right here is called my angle of elevation. I'm just going to put a little e in there. Okay? So if I go a horizontal line looking up, that's my angle of elevation. I'm elevating my line of sight. And so if I'm elevating it, whatever I'm looking up at, that's going to be good. Okay? So they might refer to things today in your notes as angle of elevation, or the other one's called the angle of depression. It was nice with math. Oops. One P in depression, right?
Yes.
Just checking.
Oh, in English, right?
I would spell it and then it looks wrong and then second guess myself. All right, cool. So angle of depression. Now, angle of depression is similar to angle of elevation. You're elevating your line of sight right here. So if I'm looking flat and then I look up, that's my angle of elevation. Depression is the same thing. You're just going from your line of sight and then looking down. So this one's going to be a line of sight. That's my horizontal line. And then if I look down right here, that angle is called my angle of depression. Okay, so angle of elevation is up, depression is down. Up, down, up, down. Elevation, depression. Okay.
Okay.
Now, if I were to mix those two together, let's say I put those two on the same kind of shape right here, right? Let's say I got my line of sight right here. Okay, and I go up to my angle of elevation. That would be this angle right here. Now let's say I was looking up at something. Who knows what it is? We'll draw fun pictures in a second. And then we're going to go let's say I'm standing up on top of something and I do my angle of line of sight like so, and my angle of depression is right there. So this is me. This is you. And we're looking at each other. Okay, so you're down here looking up, angle of elevation, that's this. I'm looking down, that's my angle of depression. Okay? Now, what do you notice about the angle of elevation and depression? They're equal. Why are those two angles equal?
Those lines are parallel.
These lines are parallel, okay.
And that's a starts with a T.
Yeah, it does start with a T.
Wait, what? Oh, they're
Transversal. Yeah, good call, good call. I know, it's been a long time, huh? Yeah, this is actually called the transversal right there. These are my parallel lines, okay? Now, those are my parallel lines. Those angles were called something. Alternate interior angles, right? So those are alternate interior angles, which makes them congruent. So these lines are parallel. They're both lines of sight. They're both flat lines, either looking up or looking down. And then those are alternate interior angles, and they're always going to be equal. Okay? So usually angle of elevation people get, no problem. Angle of depression just stumps people for some odd reason. I'll explain why in a minute. Okay? All right, fun pictures. Here we go.
Are they always equal?
Always, no matter what. Don't they have to be? If I'm looking horizontally, flat line, either up or down, right, and I'm looking up here, horizontal line, those lines are always parallel, right? So no matter what, my angle of depression and elevation, as two things look at each other, they have to be equal. Always, always, always. Okay? All right, so the house is on fire. Okay, here's our building.
Why is our house on fire?
Because somebody was boiling water, and they left the frying pan to stay on the, and all the water boiled away, and then it burnt the frying pan, and then that caused smoke, and then burnt the frying pan, and then smoke and stuff. I have no call it to that. Okay, so, and this was Isaac, and he managed to escape to the roof of this burning building. And then the savior, Mr. Gumke, because he's a fireman. So we're going to drive my fire truck.
Usually they're boxy.
I'm going to save him. I'm going to save him with my ladder. Here's my ladder. And now the maximum reach that my ladder has is 110 feet. And I got to see if I can save Isaac. A couple of the little tiny numbers that I have. I know that my fire truck is 12 feet tall. So that's from the top to the bottom of my fire truck. And then to optimize the ladder, I don't know if you guys have ever put a ladder against something. If you put the ladder too steeply against it like this, it just falls down, right? And if you put it too close to the house, what happens then when you get on the ladder? It goes backwards, right? So the fire department has decided that 72 degrees is the optimal angle of elevation. So I'm going to cheat and tell you that this angle right here has got to be 72 degrees for insurance purposes. We'll get sued if we change that angle. Okay? It's got to be 72 degrees. Then we need a different fire truck. Or the ladder can go down a little bit. But that's the maximum reach, 110 feet. What I want to know is if I can reach the top of this building, hopefully, that's first off, can I reach the top of the building? So how tall is the building? That'd be this big X right here. And the second thing is how far away should I park the truck from the building? Okay, so I'm looking for how far away the truck is. Just like so. Okay, so I'm looking for how tall the building is, what's the highest my 110-foot ladder can reach, assuming the maximum, the optimal angle is 72 degrees, and then my truck is 12 feet tall. How far away do I park it, and then how high can I possibly get? Okay. So on this one, basically, you're just solving a triangle. You're solving this little triangle right here. Well, hopefully, you're not doing the leaning tower of pizza. It's perpendicular, straight up and down. Okay, it's not leaning or anything. And now I got to try to figure out what this guy is right here. Well, I do know that this part right here is going to be 12 feet. That's from the top of the truck right here. And so I'm actually going to solve for this little piece right here. Maybe put a little Z right there. I'm going to solve for this height. Solve for this height, and I'll just add 12 to it. And then, of course, not too scale.
I think that was necessary. 18 people.
All right, so I have to figure out which trig function to use here. I'm actually finding a side length looks like. So I'm finding a side. I would probably use the sine function. So if I did the sine of 72, that's going to equal opposite over hypotenuse. That's z over 110. Okay, if I'm going to find out how far away I want to park the truck from the building, I would use cosine. So I'm going to use cosine of 72, and that's going to equal y over 110. Z is from here to here. Cool. It's so good. And now we just multiply by 110 by both of those, and that'll give me z and y. So z is going to equal whatever the sine of 72 is. And I'll multiply that by 110. So I'm going to get 104.6. 4.6. And then as far as parking it away from the truck or from the house, let's see, or from the building, it's going to be 110. And so 34 roughly. So then y is going to be 34 feet. So I'm going to park 34 feet away from the building. And then from the bottom of my ladder, it's going to go up 104 feet, or 104.6 feet. Add up the height of this building right here. So my total x here is going to be, looks like 116.6 roughly. Okay, so my building can reach 116 feet roughly.
Why would they care how tall the building was?
Because they want to see which fire truck to bring. They can save money by bringing the smaller ladder fire truck. I thought of it all. Now, let's say we were Isaac, right? Let's say we were Isaac. We're Isaac, okay, so imagine that. Okay, we're Isaac, and we want to know what the angle of depression is. It's not depressed, not going to jump up. No. He wants to know the angle of depression, horizontal line looking down. Now, all too often, people say that this right here is the angle of depression right there. Because they want to put it inside of a triangle. They're dying to put those numbers inside of triangles, okay? It's got to be from a horizontal line, which is this line, down to the ladder. That's my angle of depression, okay? Now, how big is the angle of depression there? 72, right? It's the same as the elevation. Elevation and depression are always going to be the same no matter what, okay? So if they give you an angle of depression, you can actually just put it in the angle of elevation spot and get the same answer. You'll get the right answer. Do it that way, okay? Good.
Yeah, because this.
Okay, one more and then we're done. Okay? We get to draw a pool.
Yeah, we did that.
Do I need to touch table?
Draw a diagonal or something. There you go. That looks. Wow, you can die. I'm talented. What is that? A splash.
Monty Python. Okay, kind of looks like his head's exploding out.
It doesn't have his hands like this, so his head is going to hurt. Okay, and then we got Mr. Gumke. He's doing water aerobics. Right here. And I want to walk you. And I want to walk down here. You know when you look at stuff underwater and it looks bigger? We're no longer
not underwater.
All right, I want to find my angle of depression, which is going to be this angle right here. And I'm going to give you some things. I'm going to tell you it's 20 meters across on the top of the pool, all the way across here. It's 1.3 meters right here from where our horizontal line goes. And then we got 2.9 meters. Doesn't work. That's meters.
Doesn't work.
It's a little kiddie pool, you know.
There's a giant.
But I'm doing water aerobics.
Doesn't work.
Okay, so we want to find the angle of depression, which is this angle right here. So all we do is basically we can transfer numbers across. So like this 20 is going to be this 20. So that's going to be equal on the top and the bottom. And then we can solve this triangle right here. From x right here, we have 2.9 is the opposite. 20 is the adjacent. So this one would use tangent. So we'd say tangent of x degrees equals opposite over adjacent. So 2.9 over 20. Okay, now this one we're actually finding an angle now. So we'd use our arctangent or our inverse tangent or tangent to the -1. All those are the same thing. So x is going to equal inverse tangent, -1 of 2.9 divided by 8.25. Cool. 8.25. Okay, so that's my angle of depression. Okay, that's from the horizontal line looking down.
2.9 over 20 is what we're first.
2.9 over 20, and then arctangent that. Yep. And we get 8.25. That's the angle of depression. Which, if you drew a horizontal line here, that'd be my angle of depression right there. It'll also be the same angle. Okay, so if I were standing there, my angle up would be the same degree. Okay. All right. Cool. Awesome. All right. Let's be done for today. So page 526. I worked all night last night working on what picture I would draw.
Oh, no, you're so committed to your work.
So committed to my work.